Intermediate Algebra for Statistics, Finding Quadratic Models, Part 2. Lesson Objective: determine whether to model a situation by a linear model, quadratic model, or neither. Lesson Objective: Example 3. The number of federal documents that are classified has been increasing. So has the cost of keeping these documents secret. See the table. Let C be the federal cost of secrecy in billions of dollars in the year that is T years since 1990. Find the equation of the model to describe the situation. So our independent variable is T, number of years since 1990. So in this case T is 7, T is 8, T is 9. Our dependent variable is the cost. We will use a calculator to graph the scattergram. We will also use the graphing calculator to find the linear regression model, which we've done before, an exponential regression model, and we'll talk more about exponential functions later in the course, and the quadratic regression model. And then we will see which one fits the data pattern the best. So an exponential model of the data fits the data well. And here we have a zoom out view. This is what an exponential function looks like. For the quadratic, it looks like it's fitting the data well also. And of course, with the quadratic, we have a parabola. So we have two totally different functions that are trying to model the same data set. So let's enter the data in list 1 and list 2. T is list 1 and the cost is list 2. We use our stat plot and zoom stat. Here we see the graph of the data. First we will find the linear regression model for the data. So if you recall, you hit stat, then calculate, then number 4, linear regression. Hitting enter from the home screen, we have our slope being 0.56 and a y-intercept being -1. So linear regression model is L of t equals 0.562 t minus 1, rounded to 3 decimal places. Let's see how well this line fits the data. So we type in the model in Y1, hit graph, and it's doing a pretty good job of modeling the pattern. Next, let's do a quadratic regression. So you hit stat, go to calculate, and then number 5. From the home screen, hit enter, and we get our values of A, B, and C. So for the quadratic regression model, I want to call it Q of t. We have it equal to 0.064 t squared minus 0.788 t plus 5.75, rounded to 3 decimal places. To see how well this regression model fits the data, we type the model in Y1 and hit graph. It looks like the quadratic regression is fitting the pattern better than the linear. Our last one is exponential. So if we hit stat, calculate, and then 0, which is short for exponential regression, we hit enter from the home screen. And this is the form of a exponential function. We have a value of a, we have what's called the base b, and it's raised to a variable power. So in this case, a is 1.441 to 3 decimal places, and the base is 1.12. So the model for the exponential regression would be E of t equals 1.44 times 1.12, and this is raised to the t power. Now again, we will talk more about exponential functions later on in the course. Putting this in y1 and hitting graph, we see that the exponential is doing a good job of modeling the data. So the question is, which one is doing the best job? Is it the linear, the quadratic, or the exponential? Well, to help us answer that, we will have the calculator compute what is called r square. R square is a value that is in between 0 and 1. The closer to 1, the better the model. So whichever model has a larger r square value, it will be a better model for the data. To have the graphing calculator compute the value of r square, we first have to go to catalog, which is second and 0. We want to scroll down until we see diagnostic on. So these are in alphabetical order. Hit enter. This pastes this into the home screen. Hit enter again, and it says done. Now you only have to do this once. What diagnostic on will do is compute the value of r square for each regression model. So for the linear regression model, r squared is 0.94. For the quadratic regression, r squared is about 0.99. And for the exponential, r squared is 0.97. So using r squared, the best model to use is the quadratic regression model. It's better than the linear, and it's better than the exponential. Let's talk about the process. When performing step 1 of the modeling process, we must decide whether a linear function, an exponential function, a quadratic function, or none of these is suitable for modeling the situation. Here are the criteria for selecting a model. The graph of the model should fit the points well, and we do that by using the scattergram, or scatter plot as it's sometimes called. The model should make sense within the context of the problem. Define the model and make estimates and predictions. Number 1, we create a scattergram of the data. Decide whether a line, exponential, curve, a parabola, or none of these comes close to the points. Number 2, find the equation of your model. And of course we want to use the graphing calculator to do this. Number 3, we verify that the equation has a graph that comes close to the points of the scattergram. Number 4, we use the value of r squared. The closer to 1, the better the model. Number 5, we use the equation of the model to draw conclusions, make estimates, and or make predictions. Thanks for watching.